The year is 2022 and you'll probably find hundreds of viable options to choose from if you want to build a web app. In this video, we'll take a look at two JavaScript-based tools which are enabling a much easier and quicker development process. We'll create a backend REST API using Deno, a modern JavaScript runtime environment which comes with TypeScript support out of the box. On the front-end side, we'll build a small web app using Svelte, a fairly new framework which really gained a lot of traction in recent years. Finally, we'll deploy all this in the cloud in a very easy and quick manner, all for free. By the end of this video, you'll know all the important concepts to build scalable REST APIs with Deno, and you'll be able to build basic UI interfaces using a pretty powerful front-end framework, Svelte. Without further ado, let's jump right in. Deno has a straightforward installation guide on their main page, so please follow that to set up your environment. In my case, I'm working on a Mac, so all I needed to do was to run this command in my terminal. We'll build a small app that allows us to create a list of favorite movies. After creating the project folders, let's quickly test that our Deno environment is ready by doing the usual hello world example. We'll log a string in the console and we can execute the index.ts file using the Deno run command. Things are looking good, so we can jump in the IDE and write some actual code. I'm going to use Visual Studio Code since it has good Deno support. Start by creating a .vs Code folder so we can easily customize our IDE experience for Deno development. Next, add a domain folder for the data model, a middleware folder about which we'll discuss a little bit later, a routes folder where we'll map the HTTP requests, and a services folder for the business logic. Finally, I'll create an environment.ts file where we'll store various properties or constants needed to run the app. We will be using the Oak framework to handle incoming HTTP requests. One particularity of Deno is that it doesn't use a central dependency management file to keep track of all third-party packages used in your project. Instead, it allows you to import from packages hosted directly on the web in any of your TypeScript files. There are pros and cons to this approach, and there are some conventions we can use in order to manage dependencies. We'll discuss all this a bit later, and for now, we'll simply import the necessary tools directly from the deno.land website. Working with Oak is straightforward for the basic use cases. I'm creating an application instance which will listen for the incoming requests, and I'm defining a router which will be able to map the request to our functionality. Once we register the router in the application, the server can be started and will be listening to the 8000 port. In a new terminal, we'll start the app using the Deno run command, but since the traffic will pass through the network, we have to explicitly let Deno know about this. One of the main benefits of Deno is that it really focuses on the security aspects. We successfully made the GET request to the server and we received a string as a response. It was that easy. The next thing we should do is to extract the routes mapping in their own files. These mappings tend to grow in size while your API is becoming more complex. The idea behind the setup.routes.ts is that any single page application needs to do an initial call to the backend in order to fetch some relevant data and render some meaningful UI. Oh, by the way, it's time now to quickly populate the VS Code config file since the IDE doesn't know how to handle Deno imports. These two JSON properties are the only things you need to make everything run smoothly. I'm defining a setup routes object and an init get request mapping. We'll work on the handler implementation in a second, but first let's quickly clean up the index.ts file and link our new router object in there. You'll find various ways in which people are managing app routes. Some prefer to have all mapping declarations in a single file, while others are splitting the route's path definition and the actual handler implementation in separate files. To some extent, it is on you to decide what's the best approach for your use case. I come from a Java and Spring backend background, so I prefer to split the routes based on the domain they are targeting and have both the mapping and the handler implementation in the same place. We'll discuss this in more detail in a second. Let's first define the API endpoints to work with the movies entity. Here we'll be able to search for movies, get details about them, and add or remove them from our favorites list. So we'll define a get method for the /movies/search path, and a get method for movies/id to get the details. Notice here that the ID is defined as a path variable, so we'll be able to extract it in our handler. We'll also add a post mapping to add a movie to our favorites list, and a delete mapping to remove it from the list. Then, let's add the handlers in the same file so we'll be able to easily work on anything routes related in the same place. You might find it easier to move the handlers outside of the routes file. I don't have a strong opinion on the matter, the best solution is the one you'll find easier to maintain. Just like we did with the setup routes, we'll register the movie routes in our app. I'll quickly mention the allowed methods function here as well, since it's important for you to also register it in the app. This enables Oak to appropriately send error responses when specific methods are not implemented. With the routes in place, let's spend a little bit of time working on some of the handler implementations. For the setup init request, I want to return a random ID to the client so that we can uniquely identify each user pinging our API. The convention will be that if a client receives a unique ID, it will store this value in the local storage and it will always send it back with each API call in the request header. This is a fairly common approach, but most of the time this unique ID will actually be replaced by a JWT token. To generate a unique ID, we'll use a third-party library from Deno land. There isn't anything too interesting about this implementation, so we'll get right back to the init function handler. Okay, so things are pretty straightforward. If an incoming init request already has a header containing a unique ID, we'll return the same ID in the response body. Otherwise, we'll generate a new unique string and return that instead. We'll see how to handle this on the front end in the second part of this video. Usually, a REST API is backed by some sort of database, either relational or non-relational, where we can reliably store user data. This is a complex topic since the number of databases providers and available libraries is fairly large, so we'll save this topic for a later video. For now, we'll store the user data in a static structure inside the memory. The approach will allow us to develop and test our API in a reliable and quick manner, but keep in mind that the user data will be lost whenever the server is restarted. I'm creating a new service file to handle the favorites business logic, and I'm starting by defining the structure we'll use to keep track of the favorites movies for our members. The favs object literal will have string keys where we'll store the unique member ID we generated earlier and the list of movie entries. If a member adds a movie to the list on the front end, we'll add it in the entry list. If the user removes the movie from the list, we'll update the entry list accordingly. With the getFav method in place, we can wrap up the implementation of the init request handler. So, in the end, this handler will return the existing ID or a new one if needed, and the list of favorite movies for the associated ID. With this data, we'll be able to display some meaningful content on the front end when a user will access our app. Let's work on the favs routes handler next. The first thing we need is access to a list of real movies. The moviedb.org website offers a great free API we can use to access and search through real movie titles. Go ahead and register on their website and follow the steps to generate an API key. With the generated key, we will make some updates in our environment file. It is a good practice to keep information such as this in a dedicated file. You'll have a centralized place where all configuration happens, and you can easily overwrite things in here for testing or staging environments. In a newly created file called movie.service.ts, I'm going to add some logic to work with the MovieDB API. Deno is after all a JavaScript runtime, so we can reliably use the fetch API to make HTTP requests and get information back from different websites. The movie database API has very good documentation. I'll make a get request to search/movies to get back a list of movie suggestions based on a query I'm sending as a parameter. Then, I'm extracting the results from the JSON response and I'm mapping the received information to my own DTO objects. I already prepared an interface with all the information we are receiving from the movie database API. You can see that this is quite extensive and there is no reason to send all this information over the wire if our frontend will only use a small part of this. There is a very easy solution we can apply here. I'm defining a movie DTO interface and then I'm mapping the raw data to objects following the movie DTO structure. I'll quickly fix the import in the movie service file and now we can call this method in our route handler. In the search method, we are receiving the awk context as the first argument. From here, we can extract all the necessary information, including the search key sent as a request parameter. Don't worry, we'll test this in a second in Postman and you'll get a full picture of how this request should look like. As a side note, I find awk default method of extracting parameters pretty cumbersome. I come from a Spring background where such things are solved a bit more efficiently. You'll find a link to one of my videos outlining the capabilities of Spring and Kotlin when building REST APIs, both in the top right corner and in the description of this video. We'll use Postman to test our search endpoint. Notice that we are sending the fight string as a search key, and in the bottom of the screen we receive a list of movies which have the word fight inside their names. On the front-end side, we'll use this endpoint to provide a list of movie suggestions based on the search input. The member will be able then to send back to the server requests with the movie ID he wants to add in his favorites list. Following the same approach and the movie database API, we can use the detail endpoint to return more information about a specific movie. This could be useful if you want to render a movie detail page in the UI. Since the movie ID is sent as a path variable and not as a request parameter, we need to use a helper query from awk to fetch that information. The getQuery method returns a map of all the parameters available in the request so we can easily extract the ID. We'll get through the implementation of the details endpoint really quickly since there isn't anything new worth mentioning from a technical perspective. We'll make another request to the movie database API and we'll return that information to the client. I'm jumping in Postman to quickly test the implementation, asking for the details of the movie with the 5 885 ID will return some other useful information like the poster path or the IMDb ID. By the way, even if I'm not showing this in the video, I'm always restarting the Deno app so that my code changes can be picked up. Don't forget to do the same. Next, let's work on the add movie to favs endpoint. We'll get the movie ID as a path variable, the member ID from the request headers, and an optional comment from the request body. I'm going to quickly address the topic of validations, even though this could be a topic on its own. The rule of thumb here is to always validate the user input data. In this case, we'll make sure that the request body is sent as JSON and that we indeed receive a movie and a member ID. If any of this condition is not true, we'll send back a bad request status. With this small validation in place, we can now call an add-to-favs service method, which will add the movie to our in-memory list. Also, we return a 200 OK HTTP status so that the client will know the request was successfully handled. The implementation of the add and remove from favs service methods is, again, of little interest for the current video. There isn't anything too complex in here, and we are just making sure that the list of favorite movies is correctly maintained. Going back to the remove movie route handler, we'll use the same approach I mentioned earlier to fetch the request data and to perform some basic validation. Keep in mind that the specification doesn't allow for delete requests to have any information in the request body. And this sums up the implementation of some basic API endpoints in Deno. In a couple of minutes, we'll call this from a front-end app, but in the meantime, let's quickly test the new endpoints in Postman. The post route successfully returns a 200 response status, and the list of favorite movies is correctly returned by the init get request. There are a few small tweaks I want to make before deploying this to Deno Deploy. I mentioned earlier that Deno doesn't need a centralized mechanism to register third-party dependencies. You saw that we can easily load libraries from an internet URL, and we don't need to run any install command. However, it is recommended to keep track of your dependencies and use a deps.ts file where all third-party libraries are defined. The main benefit of this approach is easy maintainability and, of course, a clear overview of what type of third-party code we are relying upon. Just like with anything, too much flexibility could turn out to be error-prone if not correctly managed. So, to avoid any long-term issues, I'm refactoring all the external dependencies to point to my dependencies file. Another small adjustment I want to make is in the favs service file. I will replace the favs object literal with a map instead. This has nothing to do with Deno, but with basic JavaScript approaches. Overall, maps are more flexible than object literals, and in general, they also come with a slight performance advantage. The main reason I'm doing this, however, is to simply maintain my code clean and up to the best standards. I promise we are almost done with the refactoring, but I want to briefly mention the concept of middleware. These are functions which are executed by the application in a predictable order in the request-response cycle. You can use them for things such as logging, error handling, course permissions, and more. Oak itself is a middleware framework on top of Deno's native HTTP server. In this case, I'm simply adding some basic logging to figure out how much time a request needs to be resolved on the server. The implementation is straightforward, and we can simply register the functions in our Oak app using the use method. And since I mentioned course, I'm also going to register it into our app. In short, this will allow us to whitelist requests coming from different sources. Usually, the server will accept and resolve the same requests coming from a front-end app hosted under the same domain. We'll develop our front-end app locally, so requests coming from localhost will be blocked without us enabling course. In production, you should be careful on what domains or origins you are whitelisting. Now we are almost done with the backend work. The final step in this process is to deploy our app so it can be reached from anywhere in the world. This used to be a pain in the past, but luckily for us, Deno Deploy makes this process really easy. They have a pricing plan you should check out. For basic usage, however, this service is free. We'll start by signing up, and after the onboarding process, we'll end up in the dashboard. My code is committed into GitHub, so I'll simply link the two accounts together. Then, it's pretty much a point-and-click process to select your repository, the production branch, and the index.ts file, which is the main entry point into your app. Click on the link button, and after a few seconds the dependencies are downloaded and your app is deployed and reachable to a custom domain. It doesn't get easier than this. We'll jump into Postman to quickly ping our app hosted with Deno Deploy, and we successfully get a 200 response back. With the backend API available at a public URL, it's now time to focus on developing a front-end app with Svelte. By the way, you can check out my Svelte first impressions video, linked both in the top right corner of this video and in the description. The setup is straightforward, so I'll not go into any details. In my project root folder, I'm just adding a new directory called app, where the Svelte app will be developed. Then I'm going to create my project structure. Create a folder called API where we'll host our files containing fetch calls to the server, a domain folder to store the models, a lib folder for our Svelte components, and a service folder which will contain any business logic related to the app. Finally, let's also create an environments.ts file to store any constants or config information we might need. In the main app component, I'm adding a couple of styling rules for the body using the Svelte special global selector. As a side note, I'm not going to cover any CSS styling in this video, and I'll just paste in some rules I prepared ahead of time. If you're interested in CSS, check out my quick intro into CSS video I linked in the description. Our app will allow us to search through the list of movies available at the movie database service, so we'll start by creating a search input component where we'll do just that. In real life projects, I advise you to use a component library which will simplify UI work for you quite a lot. There is a wide variety of options out there since, in most teams, writing components such as dropdowns or autocompletes from scratch is accepted only for very special scenarios. I'm registering a key app event handler on an input field, and as a first test, I'm just going to print the user input into the page. With that working, it's time now to make our first fetch call to the backend. I'll create a movie API file, and here I'm going to define a search method. We've seen fetch calls in the backend implementation as well, so things should be straightforward. I'm defining the backend API public URL as a constant inside our environments file, and I'm simply performing a get call, sending the search key as URL search params. There are libraries such as Axios which simplify the work with async calls, but I find Fetch good enough, especially since it has native support in all modern browsers. It's worth mentioning that with tools such as Swagger and OpenAPI, you could auto-generate all this fetching code based on the API description, so keep that in mind for your next large project. Getting back to our code, we should receive a list of suggestions once the get call is successfully returned. To render them in the page, I am simply going to use an each block inside the template part of my component. Remember to always use keyed each blocks to follow best practices. The rendering itself is very straightforward. I'm going to display the movie poster as an image, the title, and a few details about each suggestion. Since we have TypeScript support, I also defined the movie structure inside our domain file, so we can benefit from things such as autocompletion at development time. With all this in place, we should finally be able to see something meaningful in our page. Typing in a few letters will trigger searches on the backend, and the results are nicely displayed in a dropdown. It's worth mentioning that my implementation is not the most efficient one, since we are triggering backend calls after each keystroke. If this was a real project, I would probably use a debounce mechanism to only trigger calls when the user stopped typing. Next, I want to display a modal with the movie details when the user clicks on one of the suggestions. In Svelte, child components can notify or communicate with parent components by dispatching events. In the main app component, I am registering an event handler for the onSelect event. The movie ID we receive in this function will be assigned to a component property called selectedMovieID. When this property is greater than 0, we'll conditionally render a movie details component. In the newly created movie details component, we'll export a variable called ID. In Svelte, exporting values will declare them as component parameters. There are a few things a bit more interesting here. We need to fetch the movie details every time the ID property changes. We'll be using a $sign label block to monitor for the ID changes and perform backend calls. The $sign label is Svelte's way of dealing with reactivity. It's a really interesting and new approach in the frontend space, especially since these blocks are evaluated at compile time. Svelte comes with a few innovations such as these, and I advise you to dedicate some time on this matter, since I expect the new approaches will redefine the way we look at frontend development moving forward. Back to our code, I defined a fetch call to get the movie details, and now I'm working on the templating required to render this data. I'm skipping through some of this code since it's pretty much just HTML with some small bits of Svelte templating in between. All this code is committed in a public GitHub repository mentioned in the description, and you can easily see the entire implementation in there. The final thing we need to do is to allow users to add movies to their favorites list. I'm defining a heart icon component, which is just an SVG element which triggers an on-click event when clicked on it. As you probably recall, we were using a unique member ID to identify requests on the server, so we need to actually get that from the backend and use it in our add to favs implementation. To do this, we'll jump back into our main app component and we'll call the init endpoint. Svelte allows us to run code at different points in a component's lifecycle, so we'll make our call when the app component is mounted to the DOM. In theory, this should happen only once, so it is the perfect spot to get the initial data we need to get started. The init endpoint will return the unique member ID and the list of favorite movies, so we'll assign those to a local component state variable, and we'll get back to it in a second in order to also render them in the page. We need to store the unique member ID locally since we need to access it anytime we want to link a request to a specific user. The best place to do this in our case is the browser local storage. You can choose any other option you want, like the session storage for instance, but the idea is to be able to hold the ID even after a page refresh. I created a small storage service file to handle the interaction with the local storage, and now we can jump to the init method implementation. We'll do the usual fetch get you should be used to by now, but we'll also add a unique member ID as a request header. Remember that the backend will return the same ID if we are sending it to it, or a new unique ID if there isn't one in the headers. At this point, every time we access our app, we can be certain a unique member ID is in the local storage, so we can go ahead and finish the add to favorites implementation. In the movie details component, we'll make a backend post call to send the movie in the list, and we'll also dispatch an event for the parent component. The parent app component needs to know when the heart icon was clicked so that it can close the modal by setting the selected member ID to 0. We'll send the movie poster as the favorite comment field to easily retrieve it for rendering purposes. Keep in mind that, for time reasons, I'm jumping over some steps in the implementation. You might need to also handle API error returns, timeouts, and any other scenario other than the expected behavior. I'm quickly updating the movie API implementation for the post method, and we are finally close to wrapping up this whole effort. The final updates we need to do are in the main app component. First, we'll make sure that the modal is being closed when the movie is added to the list, just like I explained earlier. Also, I'm manually updating the favs list to reflect the backend changes when this happens. Another option would have been to fetch the favs list from the backend to make sure we have the quote-unquote real data, but my approach saves us one trip to the server and back. Finally, using an each block, I'm rendering the favs list in the DOM. We'll simply display the posters and that's pretty much it. In a real project, you might want to save more data in the favs list, or you might want to add a database structure to the mix to better handle the third-party movie data we are working with. We've built a pretty basic app, but hopefully it should give you an idea about all the components involved in developing a full-stack project. There are a lot of topics we didn't discuss, like databases, security and authentication, routing and more, so there are still a lot of things for you to cover. So we have our app, now we need to deploy it. One of the easiest way to do this is to use Vercel. Just like Deno Deploy, this is very intuitive and free to use for our basic use cases, so go to their website and sign in for a free account. Once you get to the dashboard, the steps should be familiar. Link your GitHub account and then select the Git project you want to deploy. Vercel has support for a lot of front-end libraries, and Svelte is one of them. Click on the deploy button and, after a few seconds, your app is deployed and ready to use. Back to the dashboard, you'll find the URL pointing to the deployed app, and, by accessing it, you'll get to your front-end app deployed in Vercel, which is communicating to your backend API deployed in Deno Deploy. And this concludes our video. If you've made it this far, please consider liking this video and subscribing to the channel. Thanks!